All right. Well, hello everyone and welcome to today's webinar, Enable Corporate IT Infrastructures with Mainframe. Before we start the webinar, I just want to take a few minutes to go over some housekeeping items. So during the webinar, everyone's phones will be muted. If you have questions, please enter them in the chat box and I can relay them to the presenter. We will be recording the presentation for future on-demand viewing. So I will now turn control over to our presenter, Gerhard Adam. Mr. Adam, you may begin.
All right, thank you. Well, good morning or afternoon to everybody. Basically, we're going to be talking today about the role of the mainframe and within the corporate IT infrastructure. We'll be looking at a few items that are related to basic skills, career paths, and of course, training opportunities. So in particular, let me just kind of introduce myself. I'm a senior instructor with WinTrack. I've got over 42 years experience within the mainframe environment as a systems programmer. Specifically, WinTrack is an AVNet training partner, and so there's classes, of course, that are available, be they private, they're online classes, and there are a variety of opportunities in terms of boot camps, specific topics, as well as a wide range of various, software skills and things that are available as far as the instructions go. I'm not going to dwell on this too much here because what we want to talk about is going to be what the role of the mainframe is, what some of the skills are that are associated, and of course, then to basically get a sense of what opportunities are available within the mainframe environment itself. So to begin, let's take a quick look here at some of the hardware that is associated with the Z-Series machine. And I don't want to dwell on the hardware technology per se, but basically is to address some of the common misconceptions that people have. As I'm sure you're all aware, there's a continuous clamoring of the mainframe is dead, everything is, different technologies, the mainframe is a dinosaur, all of these different kind of things go on. And so to many people, this is the view that they have of the mainframe. Seeing the spinning tapes, seeing the large data center, with this tape cart being pushed around or an operator sitting in front of all these blinking lights, is that very often we have this notion that the mainframe is still stuck in the 70s and in the 80s, and as a result, it represents a technology that has no future. However, the truth of the matter is that the processors that we are dealing with here now are small by any definition, but they are very large in terms of the capacity, the computing power that's available. The disk storage, tapes, for example, are all using robotic technologies, or we're going to virtual tapes where we're using a variety of different technologies in order to deal with the large amounts of data that are being managed and being maintained within the data centers themselves. You can see the Z13 processor here, relatively small footprint, about 6 by 6. And while that may seem large, it's important to remember that these are, in fact, very big, very powerful machines in terms of what they're capable of doing. And just as kind of a brief example, the Z13 processor consists of 21 octa-core processors, all right? This is not dual core or quad core. These are octa-core. So there are 8 cores per processing chip for a total of 168 cores in this machine. There's 10 terabytes of RAM memory available. We have a technology called Flash Express, which is a different way of using like solid state in order to be able to store information at very high bandwidths, and high speed. Have about 4 gigabytes worth of caching memory that's available between 4 levels of caching that exist on the Z13 processor. We also have new features like the simultaneous multi-threading as well as single instruction multiple data, which allows for single instructions now to operate against multiple data elements, as well as the ability to dynamically manage multiple threads running through the instruction flow. So these are very sophisticated, very large-scale processors. In a lot of environments, for example, you're dealing with multiple systems running that are capable of managing multiple images, a variety of different operating system configurations in even different operating systems in several instances. For example, the speed of these particular machines here, even though the MIPS rating, which is the millions of instructions per second, is not necessarily the best metric to use, you get an idea here of the basic power that is involved here. So that a total configuration consists of about 111 gig of MIPS. All right, so in other words, we basically have 111 billion instructions per second as the rough rating for the raw power on these machines. Of the 168 processors that are available, 141 of them can be directly configured for operating system use. The remaining represent additional processors, which are used to support the I/O subsystem, as well as other specialty processes that may in fact be involved in the Z13 operation itself. The I/O bandwidth on this machine allows for about 800 plus gigabytes per second to be able to be passed through this particular machine in the various channel subsystem configurations. So there's a large amount of data, there's a large amount of memory, and there's a large amount of processing power available on these machines. Just to give you an idea, one of the configurations that you can run involves a virtual machine operating system which is capable of running Linux images. The Linux images themselves then can represent the various servers. And at this point, the Z13 processor can run 4,000 servers under a single VM operating system. So this kind of gives you an idea of the power that is being brought to bear on these types of applications. Another function that's available is the ability to logically partition the machine. Logically partitioning is analogous to the idea of virtual machines, except that this takes place at the microcode level. So it's sort of like a firmware implementation that allows you to configure the machine into multiple logical partitions, each capable of running their own operating system, each capable of operating independently of the other, and sharing all of the system resources that are available. So they can be assigned their own memory, they can be assigned their own channels for communication to external devices, and they can basically operate then as independent entities. This is often used in order to separate out production systems from test configurations. They can also be assigned a share of the total processor so that we can take the entire physical configuration and divide it up amongst the number of logical partitions that we want to run. In addition, we can join these systems together through another processor configuration called the coupling facility. The coupling facility is also one of the specialty processing engines that you can use on the Z13. And what it does is that it facilitates data sharing between applications, so that if I have databases that are running on various logical partitions, I can share data buffers through the coupling facility for very high-speed links. And what this does is that this eliminates the latency of sharing information through the disk subsystems or disk technologies, which are relatively slow compared to the memory speeds and the high bandwidths available in direct processor communication like this. Systems that are configured this way, they end up sharing policy information with respect to the configuration itself. They share a timer mechanism so that all systems see the same time. And they, of course, have the applications managing the data structures that can reside within the coupling facility. You may have multiple coupling facilities. They can serve as redundant backups to each other. They can also serve for duplexing data structures. And in fact, most of the coupling facilities can also be configured to have battery backup so that there's no loss of data even in the event of a power outage. So essentially, this represents some information about the types of processors that we are talking about when we are talking about mainframe technologies. For additional information, if you want to get more specifics on some of the hardware itself, these are some of the manuals that are available. You can easily Google search for these, or you can in fact go to the IBM Redbooks portal and find all of the information on the hardware technologies, whether they be the disks, the virtual tapes, or the processors themselves. So this basically represents a lot of what's going on now in the mainframe world. And hopefully you get the idea that this is not an old, antiquated technology, and it's not a dinosaur by any stretch. These are some very fast, very powerful machines, and they are heavily utilized in some of the largest companies in the world. When it comes to the software itself, one of the things is as we mentioned already, we can go ahead and we can run several different operating systems. Now, primarily you are going to see ZOS as being the primary operating system that is used in most organizations. ZVM, which is the virtual machine operating system, is used primarily to run Z-Linux images and replace the servers, as we've mentioned already. So these would be running Linux on the Z13 machines. Within this architecture, under ZOS, we normally run the major subsystems of CICS, IMS, and DB2. There can be other vendor products that could be involved, but from an IBM perspective, the CICS environment represents our transaction processing, and the IMS and DB2 typically represent the database that are used. So that IMS represents a hierarchical database, which is intended for high transaction volumes and high access rates, and DB2 represents a relational database that is used across a broad range of applications. Again, most of these subsystems then provide the vehicle also for web services, for mobile apps, for distributed processing. All of these things can become the focal point for either receiving the data, receiving service requests, and processing the transactions that come across. In addition, we also have software that's involved as far as our telecommunication needs go, so standard TCP/IP, network connections, proprietary SNA architectures. These are all used within the mainframe environment to facilitate the communications between these different platforms, as well as other distributed platforms that they may interact with. Now, as far as the opportunities within the mainframe environment goes, given all of the technologies that are available and all of the different subsystems that are involved, there's a great deal of expertise required, because of the fact that what we have is that each of these subsystems are complex, they can be very large, and they can impact thousands of users as well as programmers and millions of customers. So generally speaking, we find that there's a high degree of specialization in the mainframe environment, so that you would have somebody that might be responsible for developing applications. They may specialize within the CICS or IMS arenas, database administrators, network personnel, storage administrators, the system programmers themselves. All of these different groups are going to be involved in managing the mainframe environment. And so there are multiple career paths available. In addition, most of the technology is upgraded on a fairly regular basis. With respect to the operating systems, on schedule, there's a new release that is introduced every 2 years. This used to be every year, but frankly, it became a little bit of a burden for installations to keep up with those constant changes. So now they're occurring every 2 years. And in addition, every couple of years, we get a new upgrade and a new generation of processors that are introduced. So again, these represent very large-scale computing environments. These are things that are constantly being updated and changed, and they represent a continuous challenge for anybody that's responsible for managing these particular environments. The Z in ZOS stands for zero downtime. And this is an objective that most large organizations strictly adhere to, so that we end up with a high degree of parallelism, a lot of redundancy, and of course, ensuring that systems do not fail, even for scheduled outages, is to minimize any impacts that occur, so that there's a fair amount of redundancy and backup to ensure that applications and services are continuously available. This is one of the most notable differences in working in the mainframe environment, is the fact that we rarely can tolerate much of an outage. And so as a result, there's a strong adherence to ensuring the systems are properly maintained, they're properly updated, fixes, patches, and things are suitably applied, making sure that you stay relatively current with your releases. All this kind of information is going to be part of managing the environment, and of course becomes a focal point for those that are working in these particular areas. So some of the opportunities that we have. Well, as we mentioned, that we have the system programming environment, and there's going to be system programmers that are involved in providing support for the operating systems. They're providing support for CICS and transaction processing, the IMS systems programmers and DB2, which are responsible then for the products, of course, as well as managing the various performance, diagnostics, all the things that go hand in hand with managing these particular environments and ensuring the viability of these subsystems. There's a lot of vendor products that are involved. Many of the products are going to be specific to these subsystems as well as those that are running in the operating system environment itself. So it's not uncommon to have several hundred vendor products that also have to be maintained. And these can range from anything from utility type functions, application services, change, problem management control, security, system automation, performance, capacity planning. All of these different disciplines are part of the various skills that are going to be associated with the general system programming kind of career path. And so there's specialization that occurs even within those areas. So that in some companies, you're going to have dedicated groups that are working in some of these areas. In smaller companies, you may have a system programmer fulfilling more of those responsibilities. But in general, the system programming arena is the one that is going to be closest to managing the software and the hardware to a degree in order to be able to maintain the integrity of the data center and maintain the continued operation that is required of such data centers. On the applications programming side, we of course have all of the development activities. And so application programming is going to involve being familiar with or being able to develop in a wide range of programming languages, so that most of the very popular languages and the common languages are certainly going to be used in addition to older languages. A great deal of the applications may very well still be written in COBOL. There's even some assembler language programming that can be involved, and there are other languages that are going to be used either within the context of support for the vendor products and other functions within the data center, such as we might use in system automation, or for developing applications that range out into the distributed platforms as well as in the mobile apps themselves. So there's going to be a wide range of application development opportunities that are available. This goes well beyond the notion that a programmer is simply maintaining existing code. There have been articles, for example, that suggest that the programs that are being run on mainframes are all legacy-based applications, and as a result, there's nothing more than just maintaining code that is 30, 40, or 50 years old. Nothing could be further from the truth. The fact is that we have current, ongoing development. It is all of the most current technology, and it is, in fact, intended to support all of the current applications. In most scenarios, the mainframe environment is the workhorse that allows a lot of these diverse applications in order to run. The Z13 processor, for example, is capable of running several billion transactions a day. And as a result, the idea of having all of these things come in and be operating in that fashion is the mechanism that is driving most business and enterprises today. So again, what we've got then is that we also have support specializations that can occur, so that we have security and storage administrators, as I said before, the performance analysis, capacity planning, systems automation teams. These are all groups that are fully engaged in managing just that environment. In the case of things like security, this is an ongoing activity, both in terms of managing the security products, administration with respect to adding users, managing existing users, as well as being concurrent with respect to the security needs of the system itself. Things like performance analysis and capacity planning are often heavily involved in ensuring that we have good response times, that we have, manage our data bandwidth, that we manage the capacity of our systems properly. Because again, we can't really afford to let any of this slide, because if the mainframe slides, then the entire enterprise suffers. So these are things that are going to be very tightly administered. There's a lot of control. There's a lot of information that's available. So when you're dealing with things like analyzing these or working with the products, these are things that are going to be heavily invested in to make sure that the data center runs the way the enterprise needs it to. System automation is also another large area because of the fact that traditionally the data center was run more manually with computer operators. But increasingly, a lot of the interactions between software and a lot of the functions that are being performed within the data center are handled by systems automation itself. So whether it be responses to system messages, startup and shutdown, a variety of things, these are all done through system automation software as well as programming that goes in support of customizing those particular elements. So what are the basic skills? Well, basically in this area here, what I wanted to mention was that just throw up a few screens, because again, some people are thinking, well, this is all green screen, it's all, not GUI interface or anything else. And yes, to a degree that's true, although there are GUI interfaces for a wide range of applications, and certainly from the user's perspective, you would be unable to distinguish between a normal web-based application running on a Windows server versus one that's running through CICS. However, if you're an application developer or if you're a system programmer, then this is likely going to be the most common interface, which is a menu-based system. And primarily, this is due to the fact that you are going to be doing a lot of typing. Editing data, being able to select various options, interfacing with different products. So I don't want this to sound like it's primitive, because there is and has been some GUI interfaces for this, but frankly, most of the time there's very little benefit you derive from it because of the fact that you spend the majority of your time either writing programs or testing, or, as I said, interacting with various utilities. So the menu-based system has been very solid for very many years. It doesn't require a lot to be able to utilize it, but it does give you a tremendous amount of access into the various functions that you need to perform, and of course, very powerful editing services. Here's an example of some of the utility functions that can be performed. And again, this is just another panel on these particular ISPF screens. All right. So in this case here, what we're going to have then is we're going to have the ability to manipulate our files and be able to do things like, delete, rename, edit, catalog, uncatalog, perform all of the functions necessary for file management. Now, for those of you that may not have any mainframe background, a data set or a file is considered the same thing in the ZOS mainframe environment. Under UNIX, you would run into these things, or under Windows, in directories, and there would be a directory path that would identify the particular file that you're going to be working with. In the ZOS environment, what we're dealing with is that we have a catalog that allows us to look up where a particular data set is located, and then we use the data set then to process. And there's going to be a variety of data organizations that are available for that. In addition, we have various types of processing where we have system tasks. We're going to have installed products. We're going to have batch processing, which allows us to basically bulk up, and do large volume transaction processing offline. We do the interactive processing with people either coming in through the web or using things like the TSO ISPF services. And then, of course, we have web services directly for customers or others that would need to interact with the system in that way. And bear in mind that we're just barely scratching the surface here on all of the capabilities and all the configuration options that are available. So again, there's a large amount of work that is being done, and there's a large amount of data that is being handled and infrastructure that is being managed through these various mechanisms. The job control language is another thing that is often used, and this is used primarily to drive a lot of batch processes. And the job control language, depending on what you may or may not have heard about it, is not terribly complicated. But one of the things that it does is that it affords you the ability to run work without your having to be there to do it. And so as a result, you can create very sophisticated jobs that involve multiple steps, multiple interactions. They can automatically be scheduled then by scheduling software. And so all of these things can be defined and established in libraries so that they can be used by operators to either start tasks or by things like the scheduling subsystem in order to be able to go out there and submit jobs, work with the dependencies, even restart jobs that may have failed, and deal with all of the interactions that need to occur in order for batch processing to work within an enterprise. COBOL programming, this is another one of those items that, again, is often considered rather archaic, but in fact, COBOL still represents a large number of programs that are out there. It doesn't mean that there aren't others, with other programming languages, but COBOL is still a very necessary skill. And so as a result, the ability to write these programs, both in terms of transaction processing as well as batch processing, still becomes a very fundamental skill for an applications programmer. REXX Programming is a language that is often used in the mainframe environment because it's an easy language to learn, but it's also one that lends itself well to being able to do batch processing, to work with systems automation, to be able to write quick routines and perform interactive functions that can write applications using ISPF, can interact with databases, it can interact with our transaction processing system, and in fact runs on a variety of different platforms. So this is another one of those programming languages that can lend itself well to a broad range of applications and allows us to automate a wide range of functions then that we normally would have had to do manually. Very heavily used in areas like system automation, as I'd mentioned, and so as a result, it provides a robust, very simple language, very light on syntax requirements, and as a result, it provides a great deal of flexibility in order to be able to code up and use these particular type of applications. In addition, one of the things that we have available to us is UNIX system services as well. Now, with UNIX system services, this may seem a little bit odd, but this is where UNIX actually runs under the control of the z/OS operating system. So going from the TSO environment, I can actually invoke UNIX system services and go into an associated UNIX environment. These environments interact with each other, both in terms of providing support for functions like TCP/IP in our telecommunications, web services, Java. A lot of these different requirements all occur under UNIX, under z/OS. The UNIX user can actually come in here directly through something like a PuTTY interface, or they can come in through TSO. And as a result, we find that this UNIX environment and the z/OS environment are tightly integrated in terms of their ability to interact with each other, as well as access to the various facilities. So the UNIX environment is capable of working with its own files in the directories and simultaneously has access to the z/OS data sets. Similarly, from z/OS, we can work with the z/OS data sets or access UNIX files as needed. So again, the requirement here now is that not only if you learn z/OS and work with the environments there, but you need to become versed in the UNIX environment as well because of the number of interactions that occur, the support that occurs between the two environments, and the ability to exploit either one in order to be able to accomplish the particular task. So this is an example of the kind of things that we're talking about within the mainframe environment. As you can see that even though we're just taking a very quick cursory look at all of these things, there's a wide range of skills, there's a wide range of areas that need support and that you would be exposed to. In addition, there's all of the cross-system type things that deal with skills like UNIX, ZOS, performance, system management, storage administration, security, and all of the range of activities that are going to cover all of those, as well as their specializations within the subsystems like database and transaction processing. So again, the idea here is that there's a tremendous amount of work that is going on in the mainframe environment itself. Now, to just kind of move forward a little bit here then with respect to the role of training in all of this, the main thing that I want to get across here is the idea that there is a wide range of training opportunities to get into this. There are several boot camps, for example, that represent some extended weeks of training with respect to learning everything from basic TSO and JCL to getting into assembler language program, to learning performance analysis, to learning assembler language or REXX programming skills or COBOL skills or the job control language. Any topic that is necessary in order to develop a more thorough understanding of the mainframe environment is available here. And as we said, this can be done as e-learning, this can be done on site, this can be done as private classes, these can be done as boot camps. Some of these classes may be a few days long, some of these classes may be weeks long. It all depends on what it is that's necessary for the skill set that is being established. In addition, some classes may be customized so that if certain customers don't need particular topics or they don't have certain features installed, then very often we can customize a class to ensure that we're providing all of the information that is pertinent to that particular customer. And as I said, if there's anything else to be gleaned out of this, is the idea that the mainframe environment is exceedingly complex as far as the full range of topics go and the full range of skills that are necessary. Just as an aside, I work with a company right now that is trying to develop their mainframe skills internally because of the fact that they are concerned about senior people retiring, and they have a plan right now to bring about 150 people into the mainframe skills arena through various training efforts. Their plan for producing system programmers right now involves a series of classes, mentoring, but basically to ensure that these people develop a level of expertise, and they consider this program to be extending out to 3 years before the individual will be considered to have sufficient skills to be able to work on their own without a mentor. So it gives you an idea that these are not trivial areas, these are not trivial subjects. There's a tremendous amount of knowledge required, and the skills that are necessary can be acquired through the various means of training here. It's challenging. It's something that can certainly keep you engaged for an extended period of time. And it's something that no matter what you do, the skills here in the mainframe environment are easily portable to virtually any other environment. So even if there's not necessarily a one-for-one correspondence, the fact is that the more generic skills in terms of analysis, program development, understanding performance, capacity planning, and all of the things that are necessary in order to really run a data center are valuable skills regardless of where they are deployed over the years. So it's something to keep in mind if you are looking at a mainframe as a future career opportunity or as just something that you're interested in. These are all some very good places for you to be able to get a lot of experience and a lot of exposure to a very high skilled, intense environment. Because as I said before, mainframes are important for keeping corporations running. If the mainframe is down, you are out of business. It's that simple. And so as a result, there's a tremendous effort to ensure that that does not happen. So with that, again, basically the idea here is that what we have is we have an opportunity for you to get more information or to find out things about the training that's available, look at the options, determine how it may fit into your own plans, as well as establishing what the needs are within the organization that you currently work for or one that you are interested in potentially pursuing. So that essentially is the view that we want to take here of the mainframe environment. Does anybody have any questions?
Well, thank you, Mr. Adam, for your presentation. It looks like there are some attendees that have sent questions directly to the chairperson, so you can do that in the chat box. You can send them directly to me, or you can broadcast your questions to the group, whatever makes you more comfortable. We have had a question about on-demand replay, so just to let everybody know, I will be sending everybody an email with a link to playback in case if there's something that you missed or you wish to review again. There was another question that was sent directly to me about what training can entail. And it's, does the training include hands-on exercises, or is it more lecture-based?
Well, that depends on the particular topic. Generally speaking, we try to have as much hands-on as is possible. So, of course, when the skill involves knowing things specifically like the JCL or TSO ISPF, anything like that, that's going to be much more hands-on. If you're dealing with topics, for example, that like system internals, or the ability to install a system, there's going to be limited amounts of hands-on because we may not have half a dozen systems available for people to be able to install or work with. In other cases, they may be paper labs. Like if you're doing performance analysis, you may be working more off of reports and analyzing data. So it very much depends on the context. But in the case of those skills that require hands-on, like programming, JCL, learning TSO ISPF, those would all be lab-oriented, hands-on courses.
All right, thank you. I have another question here. With everything moving towards the cloud, are the mainframe servers or mainframe services on the cloud?
Yes, they are. And as a matter of fact, if you are interested, all you need to do is you can Google mainframe and cloud, and you will find that there are several articles that were written like for Wired magazine and everything that talks about both mobile apps and cloud services and how they work within the mainframe. In addition, if you go to the link that I had provided earlier for the IBM Redbooks, you can find the Redbooks documentation that deals with mainframe and cloud services.
I have another question here that was sent to me. What makes mainframe training different from normal computer training?
Basically the availability. Who does it? This is something that is very difficult to acquire in a university environment unless there's an arrangement that's been made to bring in the instructors that are versed within the mainframe technologies. That's really the problem. And so as a result, you find that a lot of the instructors and a lot of the companies providing this training, they specialize in it. So it's not the kind of thing where you can sign up for, 1 or 2 semesters of ZOS assembler language or learning TSO and JCL and things like that, because most of the universities simply don't offer those classes, or they don't have the environment in order to be able to do that.
We have another question here. I don't know if you can see in the chat box, just in case if I butcher these.
Yeah, the SYSPLEX and the SYSPLEX. Yes. Yeah, basically the SYSPLEX is the CICSPLEX. Any of the SYSPLEX specifically, yes, the training is there. What we normally do is we'll have like a SYSPLEX for system programmers course, or we may have just a concepts course depending, setting up a SYSPLEX. Things like that would be involved. The CICSPLEX itself would be discussed within the CICS topics, just like if there was an IMSPLEX or any of the others. And some of the other areas, for example, like with DB2, MQ series, the use of JES and different things like that, those would all be addressed under the normal system programmers SYSPLEX classes.
So are there specific courses on IMS like transactions?
let's see, on IMS. Yeah, IMS like transactions. I'm assuming you may mean something like IDMS or database or any of those things, or are we just talking about IMS?
Looks like Mr. Lidovitz, sorry if I'm mispronouncing
okay, just
that.
IMS.
Yes, just IMS transactions.
Yeah, there would be IMS training available. And again, it depends on whether you're pursuing the applications course or whether you're looking at system programming for the IMS environment. I noticed that there's a couple of questions here dealing with things like Hadoop. All right. Yes, these are available also in the mainframe technologies. There's a lot of talk in the mainframe environment for large data. So that is definitely something that is just as much a part of the mainframe environment as all the alternative platforms. And as far as the question about what do I suggest about sticking with the mainframe or learning new technologies, my response to that is there's no such thing as too much knowledge. And so as a result, you know, anything that you can do that's going to enhance your knowledge is going to be something that is worth doing. The main point for me is that the mainframe is not a dead technology. Everything that you see, whether it be from large data to, you know, web services to mobile apps to cloud computing, these are all things that are very much a part of this environment. And so it won't hurt you to learn anything, and it won't hurt you to expand your horizons as much as possible. Can I predict what's going to happen 30 or 40 years from now? Absolutely not. But the one thing that is sure is that the more computing and the more diverse knowledge you possess, the greater the likelihood you'll find a place to settle.
All right, well, it looks like we don't have any other additional questions, but for any general inquiries, you can go to avnet.me/contact, and there you can submit a form where you can get in touch with either me or Gerhard. Let me just wait another 10 seconds to see if there are any other questions. Gerhard, did you have any concluding remarks that you wanted to add?
No, I think that, you know, most of the questions, you know, were good questions that indicate exactly the kind of diverse interests that we can run into. The main thing is that from a training perspective, we are addressing virtually every aspect. I think you'd be hard-pressed to find a topic that we don't cover. And so as a result, we've got dozens and dozens of classes ranging from everything that you could possibly want to do, whether it be applications, whether it be systems programming, the various programming skills, and the various other aspects, you know, of the mainframe environment. The only thing that you might miss once in a while is specific training for a vendor product, because very often that's covered by the vendor itself. But for the most part, if you're dealing with general mainframe training, you know, IBM oriented or the IBM products, you'll find it in the catalog list.
Also, the link on the, oh, sorry, we had another question come in. Will the presentation be distributed or available? Yes, I will be sending a copy of the link to playback to everybody who has attended today, or actually to registered, in case if there's anything that you want to review or if there's anything that you missed. Also, the mainframe training link, the avnet.me/mainframe training, that is to our Avnet Academy course catalog, so you can browse and really take a look at everything that's out there. Well, I want to thank everyone again for your interest in Avnet's webinar today, Enable Corporate IT Infrastructures with Mainframe. So feel free to use these links displayed on your screen to register for upcoming mainframe training, or if you want to contact us with any general inquiries, or you wish to go over any of these topics in further detail or ask any other questions. So thanks again to everyone for attending, and enjoy the rest of your day. This webinar is finished. You may now disconnect.
All right, thank you.